Hi, so today we're going to talk about breadth first search, also known as BFS, which is an algorithm used to search through an unknown location. And the way that it does that is through queue structures, which I've mentioned in a previous video. And it does this in an unweighted graph. An unweighted graph is where all the distances between each of the nodes or the locations are essentially equal. In addition, it searches using layers, which I'll talk about later. And it's good when the desired location is close to the starting point. Now, so I've drawn this graph over here in the black. And just to show what layers are, I also have it here in green. Now, the layers start with layer 0, which is your starting point. And then it just continues. Layer 1, layer 2, layer 3, and layer 4. This is 1. So you see how when you reorient the graph, it looks like layers. Now let's start. So first, like I said before, we're using a queue structure. You enter each node through the on queue, and then you delete it through DQ. And then it's also good to keep track of where you visited, or the outputs. So let's start at A. Now you see, where can you go from A? You can either go to B or to C. Now, because we have discovered them, we want to put them onto the queue. First, we have B, and then we have C. That's the way I viewed them. And now that I have found all the possibilities from A, we can say A has been visited. And let's cross that out. Now to the next place, B. So we look at B, and you see, where can I go next? Well, the next place is C, but we've already seen C. We already discovered it. So we can call B as visited already. And take that out of the queue and call it visited. Now the next place is C. You look at C. Where can C go? C can go to B, but we already went to B, and it can also go to D. And that is all the possibilities for C. So now that that's done, we can say C has been visited. But because we saw D, we have to make sure to also put D onto the queue. Now we look where D is. Where can we go from D? Well, we can go to E. Let's put that on the queue. We can go to F, and we can also go to G. Now, even though E is technically looks like it's behind D, it's still in the next layer. Remember, we've gone through layer 0, 1, 2, and now we're onto layer 3. So now that D has been discovered, we can take that out of the queue, call that visited. And now we go to the next letter, which is E. E doesn't have anywhere to go. That means it's already been visited and discovered. We can take that out of the queue and call that visited. We go to the next letter, F. Look, F can go to H. So now that H has been discovered, put that onto the queue. All the directions for F has been used up. So we can put F onto the visited and take that out of the queue. We go to G. G can also go to H, but H is already onto the queue, so we don't need to put that again. And we have discovered G. And now we look to the last one, which is H. And once that we realize there's no new places to go for H, we can say H has been discovered, take that off of the queue, put that to the visited, and look, we've discovered the entire graph. Now, where can we use this in real life? Well, we can use this in computer science, and you can code this into a program. But you can also use it in biology, in something called heuristic, BFS. And the idea of that is you find as many gene subsets as possible, and then you can even rank the genes by the frequency of their occurrence to potentially find tumor-related genes. It's super useful in biology. Thank you.